Hey guys, Philip here. Welcome in second part of the lecture explaining how to create third-person view in Unity. In last video, in last part, we have created movement of the camera. So we can start our projects, and I highly recommend you to follow the lecture and code along with me. And if you didn't follow the previous lecture, please watch also part 1, where I'm adjusting the camera movement, as you can see. So while I'm holding the right mouse button, I can adjust the camera. And the problem currently is that we cannot move in the direction of the camera. So when I will move to the left side, the camera, and I will press the forward button, I'm still going forward, but I'm not going forward relatively to the camera angle. Alright, so in this lecture, we'll fix this movement and we'll have a complete solution. Okay guys, so we can start. You can open your coding editors. And in our project, we should find the player controller.cs. There is already some code where I'm handling rotation, some basic rotation of the movement. What we'll do simply here, we'll remove a couple of things. Okay, so first of all, we don't need here any follow camera. We will remove this part. We need here rigid body, that's true. We don't need here camera position. We don't need here speed modifier. We can remove all of these things. In the awake, we can remove this part here of the camera position. In the fixed update, we'll remove almost everything here. We just leave here this horizontal and vertical axis. And in the late update, we can remove the entire late update. So we are starting from here. Now the movement of the player shouldn't even work, and there are not even any rotations. All right, so we are starting from the scratch. First thing we will do here, I will create here a new member variable where I will keep the movement values. Okay, so under this private of the rigid body, actually I think, yeah, we need here rigid body. Actually, we are getting here a component of rigid body. So we'll be handling also movement through the rigid body. Under the rigid body, let's write here a new private vector3. And we'll be storing here movement vector. So m underscore, let's call it movement. All right, and here I will be setting the movement as I'm getting my horizontal and vertical input values. So let's write here m underscore movement. Call here set method to set this vector, and we'll provide here for the x value horizontal input. For the value y value 0, we don't need to handle here any y direction, only x and the z axis. And for the z axis, this will be our vertical input. One thing I will check here I will check here if we are moving at all. So if this vector is a 0 vector, then we can just simply return, and we don't need to even continue executing fixed update. So I'll check here if the m movement, this vector 3 is equal to the vector 3 of a 0. This means we are not moving at all, and we can just simply return. All right, so we have our movement, and now we can actually move the player. So let's write here m underscore rb, which is a rigid body. We'll be handling it to the rigid body. Okay, let's call here method move position, where we'll provide our initial rigid body position. So m underscore rigid body position. Now we need to move in a direction of the camera actually. So let me get here a new variable after this if statement. I will call it a target direction. So vector3 target direction, where I will get my camera rotation. So camera rotation, we need to actually to get a camera rotation, we need to access here a camera. So for now, let's comment these 2 lines so we're not getting here any errors. And let's get here actually camera. So I'll write here private camera type. I will specify here m underscore camera. All right, we will get here our main camera in the awake. So m underscore camera. Let's assign here camera.main. So we'll get here your main camera. So we'll get a camera from the scene, which is marked with the tag of the camera. You can go to Unity, and basically what you will get will be your main camera here, because the tag of this camera is a main camera by the default. So you should be getting this camera. All right, so we have our camera here. We are getting it in awake. Now we can use this in a target direction. So we'll uncomment this line. And how we can get the target direction? How can we get vector 3? First, let's get here m underscore camera transform rotation. So I will get a rotation of the camera transform rotation, and I will multiply it by my movement vector. So multiply it by m underscore movement. When you are multiplying the rotation, which is a quaternion, by the vector movement, you will get a rotation of this vector. So you will basically move the movement vector in the rotation of your camera. So if your camera is rotated 45 degrees on the y-axis, you will also rotate your player 45 degrees on the y-axis. You'll see it, okay? I will show it to you. All right, so we have a target direction. And let's apply it to the position. So we'll get here our initial position plus target direction normalized. Okay, so we'll normalize it. And we'll multiply it by the speed. All right, and we'll multiply it by time, fixed delta time. Okay, actually I can specify it under each other, so it's maybe more visible for you, or maybe in a separate line, or I can just maybe make this smaller, and here is the entire line here. All right, so now we can try it out. We should be able to now move. Let's save this. Let's go back to Unity. Okay, I'll play the game. Now you should be able to move. All right, but we are moving. It looks like our vector, we are handling also, for some reason, we are going up and down when I'm pressing the forward and the backward. So somehow I'm providing the wrong value for my horizontal input, I guess. So I will close the game. Let's go back to Unity, to coding editors. All right, and let's check here our horizontal and vertical inputs. We are getting horizontal input of a horizontal, vertical input of the vertical. That's correct. We are setting it here. So horizontal input here, 0 for the Y value, vertical here. All right, if it's 0, we are resetting it here. And then we are getting here target direction. Okay, we are moving because we are also handling here Y direction. So we'll simply get here target direction, Y is equal to 0. Okay, now it should be fine. Okay, let's save it. Let's go back here. Let's play the game. Now we should be able to move normally up and backwards. All right, and we should be able to go left and the right and move the camera. Of course, everything is not working just yet because we are not rotating the player. But you can see here already when I rotate the camera in this direction and I will move in direction, I'm moving in the correct direction. So if my camera, you can see here, we'll click here on the make camera. If my camera is rotated 14 degrees, I'm also, when I'm going, let's say 50 degrees on my camera, so my camera is rotated on the Y direction, 50 degrees, I'm applying this 50 degrees into the movement of the player. So my player is moving, when I'm holding the forward key, 50 degrees rotation. It's moving this 50 degrees rotation. Okay, so now, actually it's already looking very good. Where I'm pointing my camera, I will press the forward button, so up arrow, I'm moving in the correct direction. So you can see already with a few lines of code, we have handling this complicated behavior of the movement of the player. Okay, now we will go into more difficult things. We will be handling rotation. So if I will go to the left side here, I would like to rotate also the player to the left side. Okay, so when I will go like this and I will play the forward button, I would like to also rotate the player into this direction. Okay, let's stop the game and let's go back to our coding editors. And we'll also apply rotation to our player. Okay, so under fixed update, I will create a new method, void, let's call it compute rotation. And we'll be calling this method, let's say after the movement. So after the movement, I will be computing rotation. And also we'll create here, you remember, variable private vector3. I will call it m_target rotation. And I will place my vectors under each other here like this. And also my camera here. Okay. Okay, so we have a target rotation. Now we just need to assign some value to it. So let's go back to our compute rotation method here. And we'll be computing here rotation. First thing we need to get here the direction of the camera, where our camera is currently facing. Okay, so let's write here vector3. Let's call it camera direction. We can use here a quaternion. Quaternions are used for angles usually. Quaternion, not usually, but always for a vector, for rotations. Quaternion, and you will use here Euler. All right, there you can specify here normal angles. So the Euler, you can specify normal angles in the degrees. So I will say here for x value, for 0 degrees. For the Y value, actually, I would like to get here my current rotation of the camera on the Y direction. Let's get here m_main camera. And by the way, guys, now I need to note here, if I'm not going into deep explanation, that's for a reason. This is just the implementation video. If you are looking for explanation in the details of this code, I will post some videos on YouTube from my original course, because in my original course, I'm explaining this into the details, but there is not simply time for this in a YouTube video. I need to create a separate lecture for it, because just explanations taking like another half an hour. Okay, so we are getting this camera direction. So first we are getting the rotation on the y-axis. So I will access here my main camera one more time. M_, just a camera we are calling it. Transform rotation and Euler angles on the y-axis. And for the x direction, we are getting here 0. And as I mentioned, when you would like to get here direction, you need to get the rotation, which we are getting, and you need to multiply it with a vector. So we'll multiply it with a vector 3 forward. All right, so you'll get here, this way you will get your camera direction when you will multiply camera rotation by vector 3 forward. Okay, so we have a camera direction. All right, and let's get here now. We need to get here two things. We need to get here our player movement rotation, and then we need to get the player rotation relative to the camera direction. Okay, so let's get here quaternions now, because this will be stored as the rotations. First will be movement rotation. All right, movement rotation we can get with the quaternion. In the quaternion, you have a method called from to rotation. From to rotation. There you need to provide two values. You need to provide the from rotation, from vector 3, so from vector 3 direction, and from vector 3 to direction. Okay, so from direction to the direction. Okay, so initial and final direction. Our initial direction will be vector 3 forward. And we would like to rotate the forward vector so it's facing our movement vector. So let's write here a movement vector, and we'll normalize it also. Normalized. And movement normalized. Okay, so if it's not visible, I will write it like this so you can see it. Okay, I wish I could get rid of this panel here. Maybe I will be able like this. Yeah, okay, perfect. Okay, so we are using here from to rotation. We would like to rotate the vector 3, so forward vector into the direction of the movement. This will get me this rotation, how much I need to rotate the forward vector so it's facing the direction of the player. This will get me movement rotation, and I need to apply this rotation relatively to the camera. So let's write here quaternion. Let's write here target rotation. All right, and let's write here again quaternion, and access here method now look rotation. And we will provide here our movement rotation multiplied by the camera direction. This will get me target rotation, and simply I will assign this. So M target rotation will be our target rotation. All right, and there is some small issue here. Okay, I'm specifying my target rotation as a vector 3 probably here, so it should be actually quaternion. Okay, we are storing rotations in the quaternions. Okay, so first I'm getting how much I need to rotate my my forward vector to get the direction of the player, and then I am looking for the rotation, and then I'm applying this movement rotation with the camera direction. So if my camera is rotated under some angle, I would like to rotate the player relatively to this angle. Okay, but again, if you're looking for the more detailed explanations, also with the drawings and everything, I will release a separate video. You can also find the link in the description. Okay, so this way we are getting our target rotation, and we can apply it in our fixed update. So I can call here M_RB. Let's write here a move rotation, and we'll be applying here M_target rotation. All right, so now we can save this. Let's try it out. Let's go back to Unity. Let's play the game, and now we should be able to rotate in a direction. So, okay, let's play the game. You can see when I'm facing here, like for example, left side, I will press the forward key. I'm going also rotating into this direction. I will rotate here. I'm going to this direction. I'm going to this direction, and so on. So I'm correctly rotating into the direction of the movement. There is a small issue when we are going back. You can see when I'm pressing the back key, the back direction, it doesn't work yet. We are not rotating correctly there, but we will be implementing also this solution. Don't worry, if this rotation to the back direction doesn't work for you yet, no worries, we'll be implementing it very shortly. Alright guys, let's stop the game for now. Let's go back to coding editors. And one more time I would like to get through these things here. So, as I mentioned, movement rotation, we want to, how much we need to rotate the forward vector in order to get into the direction of the player. This is the movement rotation, so that's the rotation of our player. And then we would like to apply this rotation of the player relatively to the camera direction. So we are looking for the rotation, where you need to provide a vector tree. Vector tree we can get by multiplying the rotation with the direction. So how much we need to rotate our camera in order to get rotation of the movement. Okay, so that's the rotation relatively to the camera direction. This target rotation will apply to the member variable of target rotation, and we are applying it to the move rotation method, which will be responsible for rotating our player. Alright, so now we can do small fixes and refactors of some parts of our code. So for example, the back rotation wasn't working yet for us. So actually this we can fix like this in our compute rotation. Okay, let me write here if statement. And in this if statement, I will be checking in which direction is facing my player. Okay, this will be quite a long line, so let's write here mathf approximately. I'll provide here vector tree and dot product. All right, and I will get here m underscore movement vector, a normalized vector, and the vector tree, the forward, is -1. Okay, is -1. Okay, so what's happening here? We are getting here dot product of the movement vector and the forward vector. If the result of the dot product is approximately -1, this means that we are definitely going the back direction, so player is moving backwards. And in this case, we can apply different target rotation. By the way, also vectors about dot products I'm explaining on my other YouTube videos. Alright, so this will get me that we are going backwards. When we are going backwards, I would like to apply the different target rotation. So I'll write here target rotation equals. I'll get here quaternion, a look rotation, and I will just simply get here negative camera direction. So my rotation for the target will be computed from the negative camera direction. So it will be computed as my camera would be facing the backwards. This will fix the rotation when we are going back. All right, and then I will write here else statement. Otherwise, we are going normally, and we can apply normal movement rotation. So actually, I will copy these two lines, paste them here. I will remove the quaternion target rotation here, and also I'll just specify here it like this. Okay. So we'll be checking if we are going backwards. If we are going backwards, look me rotation of the negative camera direction. So if my camera would go backwards. All right, and this should fix the rotation when we'll be going backwards. Let's save this and let's try it out. Let's go back to Unity. Let's play the game. And let's see. So when I will go backwards now, yeah, now also the backwards rotation is fixed completely. Okay, perfect. So our camera is working. We can rotate. We can move in a direction, no problems at all. I can rotate here, move into this direction, and everything is working very nicely. Okay, maybe a couple of small refactors. Let's stop the game. Let's go back to coding editors. Okay, so since we are getting here our target rotation, I think we could change here the way how we are getting here our target direction. So we are getting here our camera transform rotation. That's not necessary because we are already getting here our target rotation. So what I could do here, I could just get here m underscore target rotation multiplied by vector 3 forward, and this will get me target direction. So how much I need to rotate? This is a basic rotation of the forward vector with the target rotation. Okay, so if I specified here I need to rotate 45 degrees on the y-axis, this means I need to rotate the forward vector 45 degrees on the y-axis, and this will get me correct direction of the player. One thing we are doing here, we are getting here normalized, and yeah, actually this can stay here, or you can just remove it from here, and you can just wrap it in the brackets, and you can call here straight away on this normalized, like this. Okay, we can save this. Let's try it out. Now it should be working as before. No big deal here. All right, we can rotate correctly. All right, it's working. Perfect. Okay, one more refactor what I will do. Let's go back. I will store here also our target movement, or how we want to call it, target direction, or maybe, I guess target direction is fine name for it. So we'll create here a new vector private variable. So private vector 3 type and m_target direction. All right, I'll get here a new method under this. So I'll write here void compute direction. All right, I'll copy these 2 lines from here. All right, like this, target rotation multiplied by vector 3. All right, that's fine. And we'll be assigning it into our m_target direction, resetting the value of the y to the 0. I'll be calling this under the rotation, very, very important. It matters on the order here, so should be rotation first, then the direction. We can remove these 2 lines here. All right, and we'll be applying m_target direction here. All right, so that should be it. If you're looking for the whole code, you can find it, of course, in the GitHub repository or resources of this lecture. We can save everything. We can try it out. All right, so let's save this back to Unity, and everything should be working. And once again, if you're looking for the whole course, you can find it on Code Academy. Everything is working nicely now. And also, in my course, I'm explaining much more in the details stuff, and there is already 250 lectures and 30 hours of content, so lots of things for Unity. All right, so that should be it from this lecture. I am also posting, after this lecture, I will be posting the detailed explanations of these lines of code I was writing here. So compute rotation, compute direction, all this will be explained separately in other YouTube video. I will include a link in the description. So guys, that's it, and I hope to see you in some of my other videos. And if you like this video, press the like button. Cheers.